below. In this lecture we'll find out the area of the green shape. In the drawing we have a circle. Inside this circle we have peripheral angle ACB. This is peripheral angle ACB that is equals to 70 degrees in its size, and we know that the radius of this circle is equals to 2 units in its length. In addition, we have in the drawing the common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent PA, tangent to this circle here at point A, and tangent PB, that is tangent to this circle here at point B. Again, our mission is to find out the area of this green shape. Okay, so first of all, we also know that point O is the center of this circle. So first of all, we join points O and B together by a straight line. So point O is the center of the circle, point B is the point of the circle itself, therefore OB is the radius of this circle that is equal to 2 units in its length. So write it down. So we define the radius of this circle as R, so R equals to 2, and here also AO equals to R, that equals to 2 units. You can implement here rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle, and we have also tangent AB. This is tangent AB, that is tangent to this circle here at point M. Point M is the point of tendency of tangent AB with this circle, and we have the radius OM that is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to this rule, rule 1. So we can implement rule 1 in our drawing. Why? Because in our drawing, we have here the radius OB that is drawn to point B, that is the point of tendency of tangent PB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent PB will be perpendicular to the radius BO. If PB is perpendicular to BO, it means that this angle equals to 90 degrees, according to rule 1, of course. Likewise, according to the same rule 1, we have here the radius OA that is drawn to point A, that is the point of tendency of tangent PA with this circle. And whenever you have a radius that is drawn to the point of tendency, tangent PA will be perpendicular to the radius AO. If PA is perpendicular to AO, it means that this angle equals to 90 degrees. According to the same rule, rule 1. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing, we have a circle. Inside this circle we have peripheral angle ACB. This is peripheral angle ACB that is subtended on arc AB. In addition, we have also the central angle AOB. The central angle AOB is subtended on the same arc AB. And therefore, the central angle will be twice as large as the peripheral angle that is subtended on the same arc. Both those two angles, they are both subtended on the same arc AB. Therefore, the size of this peripheral angle AOB must be twice as large as the size of this peripheral angle ACB. And because of the fact that the size of the peripheral angle ACB is equal to theta, then the size of the central angle AOB must be equal to 2 theta. We can actually implement Rule 13 in our drawing. Why? Because in our drawing we have this is peripheral angle ACB that is equal to 70 degrees according to what is given in the question. And this peripheral angle ACB is subtended on arc AB. But we also have the central angle AOB. This is central angle AOB that is subtended on the same arc AB. Therefore, the size of the central angle must be twice as large as the peripheral angle ACB that is subtended on the same arc AB. And because of the fact that the size of peripheral angle ACB is equal to 70 degrees, therefore the size of this peripheral central angle AOB must be 70 degrees times 2, that is 140 degrees. It is twice as large as the peripheral angle ACB that is subtended on the same arc AB. So angle A, or the central angle AOB, equals to 140 degrees in its size. In the next step, we will join points P and O together by straight line. And we'll prove that the right triangle PAO is congruent to the right triangle POB. Okay, the right triangle PAO is congruent to the right triangle PBO. So, why those two right triangles congruent to each other? First of all, side AO of the right triangle PAO is equal to side BO of the right triangle PBO. Why? Because they are both the radii of the circle, therefore they are equal to each other. So, you can write down that AO equals to BO, they are both the radii of the circle, is equal to R, according to our definition, and R equals to 2. In addition, we have side PO, that is a common side, it belongs to both triangles, so we can write down that side PO equals to itself as a common side that belongs to both triangles. So, write it down. PO equals to itself as a common side that belongs to both triangles. And here we can implement also rule 2. I'll remind to you quickly what is rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing we have a circle, and we also have the common extent point point P. From the common extent point P, we have two tangents to this second, tangent PA and tangent PB. And according to this rule 2, the lengths of two tangents are equal to each other. That is to say, PA equals to PB. So we can actually implement rule 2 in our drawing. Why? Because in our drawing, we have the common extent point P. From the common extent point P, we have two tangents to this second, tangent PA and tangent PB. And according to rule 2, they are equal to each other. So PA equals to PB. So side PA of the right triangle PAO equals to side PB of the right triangle POB. According to rule 2, PA equals to PB according to rule 2. So if we want to find out that all the sides of the right triangle AOP are correspondingly equal to all the sides of this right triangle POB, therefore those two right triangles can go into each other according to side rule. So I write it down, the right triangle PAO is congruent. This is the sign of congruent to the right triangle PBO according to side rule. And for the fact that those two right triangles can connect to each other, we conclude that those two angles are equal to each other. That is to say, this is angle AOP in the right triangle APO, and this equals to this angle, this is actually angle BOP in the right triangle BPO, and they are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles must be equal to each other. So if we define this angle as alpha, then the other angle, this angle must be also equal to alpha because they are equal to each other. So if we define this angle as alpha, then the other angle must be also equal to alpha. So alpha plus alpha equals to 140 degrees. Again, alpha plus alpha equals to 140 degrees. So alpha plus alpha is 2 alpha, that is equal to 140 degrees. Here we divide this equation by 2, and we get that angle alpha equals to 140 degrees over 2, that is 70 degrees. So actually, this is angle alpha is equal to 70 degrees in its size, and this is also angle alpha is equal to 70 degrees in its size. And we find out in the next step the length of tangent PA. So what is the length of tangent PA? Here, because of the fact that AOP is a right triangle, this right triangle tangents 70 degrees, tangent 70 degrees equals to AP over AO. It again, in the right triangle AOP, tangent 70 degrees equals to AP over AO. Tangent 70 degrees equals to AP over AO. So tangent 70 degrees equals to AP over AO. AO is 2, so we substitute AO by 2. So tangent 70 degrees equals to AP over 2. Tangent 70 degrees is 2.75. So 2.75 equals to AP over 2. Here we'll multiply this equation by 2. And finally we will get that AP equals to 2 times 2.75, 2 times 2.75 is 5.5. So AP, the tangent AP equals to 5.5 units in its length. Our mission is to find out the area of this green shape. So, what is the area of the green shape? From the drawing it is very easy to see that the area of this green shape it is equals to the area of the right triangle AOP plus the area of the right triangle POB I will want to you that we already found out that those two right triangles can go into each other. So it is the area of the green shape equals to the area of the right triangle AOP plus the area of the right triangle POB minus the area of sector AOB minus the area of this sector AOB. Repeat again. The area of the green shape in total equals to the area of the right triangle AOP plus the area of triangle POB minus the area of sector AOB. The rounded line above AOB is the sign for a sector. It means this expression means the area of sector AOB. So once you know what is a sector? A sector is a portion of a circle. It is part of a circle, like a pizza slice. The sector, this green sector AOB consists of two legs. The first leg is AO and the second leg is BO. They are both the radii of the circle is equal to R, therefore they are equal to each other, and also the arc between the two radii, arc AB. So this is sector AOB, and the angle between the legs, that is AO and BO of this sector AOB is theta. So the area of this sector AOB equals to the area of this circle that contains the sector times the angle between the legs of this sector that is theta over 360 degrees. Again, the area of this sector AOB equals to the area of the circle that contains the sector, the area of the circle that contains the sector times the angle between the legs of this sector that is theta over 360 degrees. Okay. We'll use this formula in order to find out the area of sector AOB. So, but first of all, because of the fact that the right triangle AOP is congruent to the right triangle POB, they also have the same areas. So, you can substitute the right triangle POB by the right triangle AOP. We'll do it now and we'll get that the area of the green shape will be equal to the area of the right triangle AOP, and we'll substitute the area of the right triangle POB by the area of triangle AOP because they have the same areas, because they can go into each other. So it is the area of the right triangle AOP minus the area of sector AOB. So in conclusion, found out that the area of the green shape in total equals to the area of triangle AOP plus the area of triangle AOP, that is 2 times the area of triangle AOP minus the area of sector AOB. So the area of the green shape equals to 2 times the area of triangle AOB. The area of any triangle equals to the base of the triangle times the height to the base over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And you have only with the base times the height. Here the base of this right triangle AOP is 2. And the height to the base is AP. Why? Because of the fact that AP creates 90 degrees with the base AO, it is the height. So the height is AP. So it is 2 times AP. So it is 2 times, and AP is 5.5. So it is 2 times 5.5, that is 11. So in conclusion, found out that the area of these 2 right triangles AOP plus the area of the right triangle AOB, in total they are equal to 11 square units. They are equal to 11 square units. Now we'll find out the area of this sector AOB. And the area of those 2 right triangles minus the area of sector AOB is equals to the size of this green area. So what is the area of sector AOB? The area of sector AOB will be equal to the area of this circle if I reduce r, that is to say it is pi r square. It is the area of the circle that contains the sector times the angle between the legs AO and OB of the sector AOB, that is 140 degrees, over 360 degrees. So it is pi, r is 2, the radius of this circle r is 2, therefore r squared is 2 squared, that is 4. So the area of the circle that contains the sector is 4 pi times 140 degrees over 360 degrees. So 4 pi times 140 degrees over 360 degrees is equals to 3.888 square units. And the area of the green shape equals to the area of those two right triangles. We have already found out that the area of those two right triangles is 11 square units minus the area of this sector AOB. We just right now found out that the area of sector AOB is equal to 3.888 square units. So it is actually 4.888 square units. Again, four pi times 140 degrees over 360 degrees. It is 4.888 square units. And the area of the green shape in total equals to the area of those two right triangles, that is 11 square units, minus the area of this sector AOB, that is 4.888 square units. 11 minus 4.888 is 6.111 square units. So we already found out that the area of this green shape is equal to 6.111 square units. So in the next step, I will summarize the lecture. In this lecture, we find out the area of this green shape. In the drawing, we have a circle. Inside this circle, we have peripheral angle ACB. This is peripheral angle ACB is equal to 70 degrees in its size. And we also note that the radius of this circle R equals to 2 units. In addition, in the drawing, we have the common external point P. From the common external point P, we have two tangents to this circle, tangent PA and tangent PB. Tangent PA is tangent to this circle here at point A, and tangent PB is tangent to this circle here at point B. Again, our mission is to find out the area of this green shape, or the side of this green shape. So first of all, we join points O and B together by a straight line. Point O is the center of this circle. Point B is the point of the circle itself. Therefore, OB is the radius of this circle. This is equal to 2. We have the radius OB, that is on to point B, that is the point of tendency of tangent PB with this circle. And whenever you have a radius that is on to the point of tendency, then according to rule 1, tangent PB will be perpendicular to the radius BO. If PB is perpendicular to BO, it means that this angle equals 90 degrees. Likewise, according to the same rule 1, we have here the radius OA that is on to point A, that is the point of tendency of tangent PA with this circle. And whenever you have a radius that is on to the point of tendency, then tangent PA will be perpendicular to the radius AO. If PA is perpendicular to AO, it means that this angle equals to 90 degrees. Then I presented to you the new rule 13, and we implemented rule 13 in our drawing. According to rule 13, the central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing you have a circle. Inside this circle we have peripheral angle ACB. This is peripheral angle ACB that is subtended on arc AB. And we also have the central angle, angle AOB. AOB is the central angle that is subtended on the same arc, arc AB. Therefore, the central angle must be twice as large as the peripheral angle that is subtended on the same arc. Both those two angles, they both subtended on the same arc, arc AB. And you know that the size of peripheral angle ECB is theta, therefore the size of the central angle AOB that is subtended on the same arc, arc AB will be 2 theta. So we can actually implement all 13 in our drawing. Why? Because in our drawing we have the peripheral angle ACB. This is peripheral angle ACB that is subtended on this arc, arc AB. And we also have the central angle AOB. Central angle AOB is subtended on the same arc, arc AB. Therefore, according to rule 13, the size of this peripheral angle will be twice as large as the size of this peripheral angle that is subtended on the same arc, arc AB. And because of the fact that the size of this peripheral angle is ACB is 70 degrees, the size of the peripheral angle AOB, the size of the central angle AOB will be 70 degrees times 2, which is twice as large as the peripheral angle ACB that is subtended on the same arc, arc AB. Therefore, the size of this peripheral angle is the size of this central angle AOB is 140 degrees. It is twice as large as this peripheral angle that is equal to 30 degrees. So the central angle AOB equals to 140 degrees according to rule 13. In the next step, we join points P and O together by straight line. By joining points P and O, we get two right triangles, the right triangle AOP and the right triangle PBO. In the next step, we proved that those two right triangles can go into each other. So why those two right triangles can go into each other? First of all, side AO of the right triangle AOP is equal to side BO of the right triangle BOP, because they are both the area of this circle, therefore they are equal to each other. Each of them is equal to 2 units in its length. In addition, we have side PO that is the common side that belongs to both triangles, so I can write down that side PO equals to itself as a common side that belongs to both triangles. And finally, PA in the right triangle PAO equals side PA in the right triangle PAO equals to side PB in the right triangle PBO according to rule 2. According to rule 2, whenever you have the common standpoint, point P, and for the common standpoint P we have two tangents to this circle, tangent PA and tangent PB, and according to rule 2 they are equal to each other. That is to say, PA equals to PB. So actually prove that all the three sides of the right triangle, this right triangle PAO, are correspondingly equal to all the three sides of this right triangle PBO. Therefore, those two right triangles can go into each other according to side rule. And from the fact that those two right triangles can go into each other, we will derive that those two angles must be also equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two corresponding angles must be also equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha, because they are equal to each other. And therefore alpha plus alpha in total must be equal to 140 degrees, as you can see from the drawing. Alpha plus alpha is 2 alpha, so 2 alpha equals to 140 degrees. 2 alpha equals to 140 degrees. We divided this equation by 2 and finally found out that the missing angle alpha is equals to 140 degrees over 2, that is 70 degrees. So this is angle alpha that is equal to 70 degrees in its size, and this is also angle alpha that is equal to 70 degrees in its size. Then we focused on the right triangle AOP. In the right triangle AOP, it is very easy to see that tangent 70 degrees equals to AP over AO. Again, triangle 70 degrees equals to AP over AO. Repeat again, in the right triangle, triangle AOP. In the right triangle, triangle AOP. Triangle 70 degrees equals to AP over AO. So it is AP and AO is 2. So we substitute AO by 2. In conclusion, we found out the triangle 70 degrees equals to AP over 2. Here, triangle 70 degrees is 2.70 degrees, 2.75. The value of triangle 70 degrees is 2.75. So 2.75 equals to AP over 2. We multiply this equation by 2 and finally found out that AP equals to 2 times 2.75. 2 times 2.75 is 5.5. So we found out that the length of side AP on this right triangle APO equals to 5.5 units. Okay. And we have already found out that those two right triangles can go into each other, therefore they also have the same areas. Okay, because of the fact that those two right triangles can go into each other, they also have the same areas. But what is the area of the green shape? The area of this green shape, from the drawing it is very easy to see that the area of the green shape equals to the area of the right triangle AOP plus the area of the right triangle POB minus the area of this sector, sector AOB. Repeat again. From the drawing it is very easy to see that the area of the green shape equals to the area of the right triangle AOP plus the area of the right triangle POP minus the area of sector AOB. This sector, sector AOB. Okay? But because of the fact that those two right triangles can go into each other, they also have the same areas. Therefore, in this equation, we can substitute the area of this right triangle POB by the area of the right triangle AOP because they have the same areas. And we get that the green area equals to the area of triangle AOP plus the area of triangle AOP again because we substitute the area of triangle POB by the area of triangle AOP because they are equal to each other. Minus the area of sector AOB. So the area of triangle AOB, the area of triangle AOP plus the area of triangle AOP is 2 times the area of triangle AOP minus the area of sector AOB. So we have to find out the area of triangle AOP. The area of any triangle equals to the base of the triangle times the height to the base over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled and we have to only with the base times the height. The base of this right triangle AOP is 2 and the height to the base is AP. So it is the area is AO times AP. The base is AO, that is 2, and the height is AP. So it is 2 times AP. AP is 5.5. So substitute AP by 5.5. So it is 2 times 5.5, that is 11. So in conclusion, we found out that the area of those two right triangles in total is equal to 11 square units. And we have to subtract from the area of those two right triangles the area of this sector, sector AOB. A sector is part of a circle, it is a portion of a circle. Sector, the green sector AOB is a portion or part of this circle. The sector AOB consists of 2 legs. The first leg is AO and the second leg is BO. They are both the radii of this circle that is R, therefore they are equal to each other. And it also consists the arc AB between those two radii. And angle theta is the angle between the 2 legs AO and BO. So what is the area of this sector, the green sector AOB? The area of sector AOB equals to the area of the circle that contains the sector, that is actually pi r squared because the radius is r. times the angle between the legs of this sector, that is theta, over 360 degrees. Repeat again, the area of this sector A or B equals to the area of the circle that contains the sector, that is pi r squared, times the angle between the legs of this sector, that is theta, over 360 degrees. So pi r squared times theta over 360 degrees, it is the area of this sector, sector A or B. So turning to the formula that I presented to you, the area of this sector A or B will be equal to the area of this circle that contains the sector, that is actually pi r squared, times the angle between the legs AO and BO of this sector A or B, that is actually 140 degrees, times 140 degrees over 360 degrees. The radius R of this circle is 2, therefore R squared is 2 squared, it is 4. So in total pi r squared is 4 pi, that is the area of this circle. So it is 4 pi times 140 degrees over 360 degrees. 4 pi times 140 degrees over 360 degrees. In total it is equal to 4.888 square units. So we actually found out that the area of this sector A or B, it is equal to 4.888 square units. And we have only found out that the area of this green shape in total equals to the area of this right triangles, that is equal to 11 square units, minus the area of this sector, that is equal to 4.888 square units. Repeat again, the area of the green shape equals to the area of the two right triangles, that in total they are equal to 11 square units, minus the area of sector A or B, that is 4.888 square units. 11 minus 4.888, it is equal to 6.111 square units. In conclusion, we found out that the area of this green shape, it is equal to 6.111 square units. Okay, thank you very much.